The advantages of diaphragm pumps are well known. The separation of all mechanical parts, with the exception of the inlet and discharge valves, from the pumped medium makes them particularly tolerant of fluids which are contaminated or, like water, have poor lubricating qualities. The circular crankcase is oil-filled for hydraulic diaphragm activation and lubrication of mechanical parts. The Harben tubular nitrile diaphragm, with its internal supporting mandrel, allows cycling rates in excess of 1,000 per minute and produces a cylindrical pumping chamber ideally suited to high pressures. This cross-section of a cylinder demonstrates the function in full detail. Water is gravity-fed into the pump via a 150 micron filter through the inlet manifold to each of the radially placed cylinders. The water is traveling from the low-pressure inlet through the diaphragm to the high-pressure outlet. At either end of the diaphragm, there are non-return valves, one inlet and one delivery, which control the flow of water through the cylinder. On the upstroke of the piston, the diaphragm is pressurized and causes the inlet valve to close and the outlet to open. On the downstroke of the piston, the opposite happens, with water being drawn into the diaphragm through the open inlet valve, whilst the delivery valve remains closed. The high-pressure water from the cylinder is directed to a collection manifold before going on to the working nozzle. High speed, combined with a multi-diaphragm radial layout, leads to a family of pumps of compact yet uncomplicated design. Pressures up to 700 bar, or 10,000 pounds per square inch, and flows up to 150 litres, or 33 gallons per minute, are available from this design.